Dissolving a solute in a solvent is an equilibrium process, not unlike evaporation. So in evaporation, we initially had the liquid and no substance in the gas state above it. And so we had evaporation, but we had no condensation. Initially, when you dissolve a solute, the rate of dissolution is greater than the rate of recrystallization. But as the concentration of the dissolved solute increases, you do get some that comes back and recrystallizes. So if we look at a chemical equation for sodium chloride dissolving, here we have sodium chloride solid, and it dissolves to form sodium ion, aqueous, and aqueous chloride ion. But these two ions can also come together and form solid sodium chloride. And so we have a double-headed arrow here indicating that the reaction is going in both directions. We get a dynamic equilibrium when the rate of dissolution, the forward reaction, is equal to the rate of the reverse reaction, the recrystallization. So here we have it in pictures. So here we have our beaker of water and our sodium chloride crystal. When we first put the sodium chloride crystal in here, there are no sodium and chloride ions present here to recrystallize. And so all we have is dissolving, the forward reaction. As more and more ions dissolve, now we get a higher and higher concentration of sodium and chloride ions. And now we can have the possibility of recrystallization. So we have dissolving and we have recrystallizing. The rate of the recrystallization depends on how many ions are in solution. If there's only a couple of ions in solution, they have to run into each other and meet up before they can recrystallize. As the concentration of ions in solution gets higher and higher and higher, the rate of recrystallization gets higher. Eventually, we'll get to a point where the rate of dissolving is equal to the rate of recrystallizing. And so you have ions leaving and ions coming back, just like we did with evaporation. We have some qualitative terms we use to describe the concentration of solutions. A saturated solution is one where we have that dynamic equilibrium. We have dissolved solute and we have solid solute. And we have an equilibrium. The solid is always dissolving and recrystallizing at the same time. But if you just look at it, the amount of solid in there is constant. If you add more solid, if you add more solute to the solution, it will not dissolve. An unsaturated solution has less than the equilibrium amount of solute dissolved. So if we add more solute, it will dissolve. There's no solid present. A supersaturated solution seems impossible. It has more than the equilibrium amount of solute. It's unstable. And usually what happens is that excess solute that shouldn't be dissolved will precipitate out. So these solutions are very unstable, a little bit like that supercooled liquid that we had. And you look at them wrong and sometimes they'll crystallize. So here's some photographs of sodium acetate. So here the sodium acetate is dissolved in water. And a supersaturated solution is generally achieved by heating the liquid. The solubility of most substances increases at higher temperatures. And so you form a saturated solution at an elevated temperature and you let it cool down very slowly and undisturbed. And then when you disturb it by dropping a crystal into it, it suddenly realizes, hey, wait a minute, I'm above my solubility limit, and it will begin to recrystallize. And sodium acetate has such a difference in solubility over temperature that essentially the whole thing will crystallize. So I've got some videos, let's watch those.